History of the periodic table. So the periodic table, the current one that we use, was most closely related to the one that Mendeleev developed. There have been a few changes to it just because some of the things like in the long run didn't work out with number of protons and masses and stuff, but how he originally organized it was based on the physical, chemical, and properties of elements. So what he did is he took the elements and he said like, oh, look at all of these elements: hydrogen, lithium, sodium, potassium, rubidium, like voila, right? They all have the same physical and chemical properties, so I'm going to organize them all together. There were some that he was able to predict. So like these couple here, he left blank, saying that like he organized them and said like, I know that these exist because there's a pattern. However, we haven't discovered them yet. So his periodic table allowed him to correctly predict missing elements. So there were elements that were missing, like right around here. I think it was like gallium was one of the ones that he was able to correctly predict. If you take a look at the periodic table, there are a bunch of places, not a bunch, there's like 3, I think, where the mass goes up and then back down. So one of those places is right here. It's hard to see on this periodic table because it's so small, but the mass of tellurium is 127.8, and then the mass of iodine is 126.9. So it actually goes down, and then it goes back up to xenon, which is 131. So those little instances, there's a couple places that happens on the periodic table where it doesn't work out. And what happened is Hank Moseley is the one who discovered that these elements have those physical and chemical properties that are similar to each other for very specific reasons. And it was based on their number of protons and their number of valence electrons. So he arranged the table according to atomic number, so number of protons, which is why some of those got switched. So our S block elements are these elements right here. Helium is right here as well, so not over here, it's actually over here. They are the most reactive, at least in the first group. That's the alkali metal and then the alkaline earth metals. The alkali metals are the most reactive. They react with things like the air, the water in the air. Like they will burn on contact to water, so very, very reactive. Group 2, the alkaline metals are also reactive, but they can be found on their own. They can be more stable. They are more dense and they are stronger. P block elements are these guys here. So not with helium. Remember, helium is over there in that little blank spot. But the P block elements contain some metals and some nonmetals, and they contain semi-metals. So the semi-metals are right here along this line. They're also called metalloids, and they're called semi-metals, metalloids, and semiconductors. I was like, what's the other one? And that's because they share properties from metals and nonmetals. So nonmetals don't conduct electricity, metals do. So the metalloids, those semi-metals, are semiconductors. This group 18, including helium, is non-reactive because they have a full valence shell. Helium is full at 2 electrons, but the rest of them are full at 8 valence electrons. And we call those noble gases. Halogens is this group right here: fluorine, chlorine, bromine, iodine. That is our halogen group, and they usually bond with these guys over here in group 1, the alkali metals, to form salts. D block is here in the middle. So when you're doing the electron configuration, those are D. Those are the transition metals. And actually, transition metals kind of come over into this category too. Anything below those metalloids, we consider those to be transition metals too. They are less reactive. They're great conductors. They look like metal. So notice you have silver and gold in here. Sorry, I did that. I circled them backwards. Silver is Ag, Au is gold. You have things like copper. We know that those things are shiny. They look like metal. Whereas these metals don't look like metals. Most of them look like a powder in their solid form. F block is this bottom block down here, right? This is our F block, the lanthanide, which is this first one in the actinide series. They have similar properties to these guys, but they are all radioactive. That's the difference. They can all go through radioactive decay. Some of them were even man-made. It's hard to tell on this periodic table, but if you look on other periodic tables, you'll see that like these ones, actually it might even be all those, and then like up to, I want to say like here, all of those were man-made. So just as a review, this is our S block. Oops, I didn't mean to write S there. I meant to write HE. So this is our S block, and the numbers for electron configurations go like this. This is our P block. The numbers for electron configurations, they start at 2. So they actually match our S block. D is in here, and it goes 3, 4, 5, 6. And then F is down here, and it goes 4, 5. Sorry, that was F. This was D, and this was P. So you notice S starts at 1, P starts at 2, D starts at 3, and F starts at 4. And then again, these are alkali metals, alkaline earth metals, transition metals, halogens, noble gases, lanthanide series, which is easy to remember. It starts with lanthanum, and then the actinide series, which starts with actinium. So those are usually pretty easy series to remember. Please let me know if you guys have any questions.